Hi everyone, this is Hakim Yagantishwaru. Welcome back to our machine learning sessions. Today we are going to discuss one of the very important session, that is how to construct a data entry from scratch. I will show you by taking a simple example how to construct a data entry manually. You can apply the same process for any data set, and in interviews also you can explain this process how you are going to construct a data entry from scratch. What is decision entry? Means here in this example, I will show you constructed decision entry for classification problem. Here, this decision tree, it is a tree-like structure. It is a tree-like structure where root node, leaf node, intermediate nodes, and how to choose the leaf node or root node or intermediate node. I will show you the complete calculation, how to choose the root node and other nodes. The process will go through until the smaller structure and eventually associating with the incremental decision tree. Means first it will start with the root node and then intermediate node, and finally where it will end means final decision. Whether, for example, if you take diabetes problem, and it will start finding the root node which feature will be the root node, and finally it will leads whether the patient is diabetes or not. Once if you are able to construct a decision tree, it will follow the simple if-else rules. I will show you after constructing a decision tree how to perform. I will take some records and I will show you how to perform the classification by using decision tree. And as I told, final structure will looks like a tree with nodes and finally leaves. And here each time the rule means whatever the rule we are going to learn from the decision tree, and finally that training will continue until the termination point is met. Means once if you are able to classify the given input based on those rules, the training will end. There are multiple approaches to construct a decision tree. One is a Gini index and another one is entropy. So if I wanted to find out whether a root node or intermediate node or leaf node, how I am going to find means these are the two approaches. Either you can use Gini index or entropy. If I wanted to define Gini index, what is exactly Gini index or Gini impurity? So see the name impurity means if I calculate Gini index, whether I need to take higher value or lower value of that feature in order to make it as a root node means the name itself it is telling, right? It is impurity. Means if I choose particular feature, how it is randomly classifying that record as a wrong incorrect classification. So for example, if you see a diabetes problem, there will be different features like glucose, body mass index, and so on. For example, if you take glucose, how it is wrongly classifying the that record. So if I wanted to take that Gini index for any feature, I need to take the lower value. If it is higher value means it is wrongly classifying, more wrongly classifying that particular record. So that's why the feature with the lowest Gini index will be placed at the root node and next intermediate node and next a leaf node likewise. We'll see with complete calculation with simple example. And formula for Gini index is 1 minus summation of I equal to 1 to n pi square, where pi is the probability of that particular feature. For all the classes, we need to calculate the probability. We'll see with an example. And similarly, entropy is also one of the measure which is used to find out the root nodes and other nodes in the decision tree, which is also describe the information that is needed to accurately describe the some sample. And if all the samples are of same type, then entropy is zero. And if equally samples are divided, then entropy is maximum 1. So Gini index or entropy, the maximum value 1 and minimum value is 0. The value of a Gini index and entropy will lies between 0 and 1. And see this, we are going to construct a decision tree like structure. For example, this is an example whether play will happen or not. There will be multiple features like outlook, humidity, overcast, and wind. So we need to find means how we have chosen outlook as a root node, and how we have chosen next node as a humidity or overcast or wind. So we'll see with an example. So we are going to construct this decision tree with sample data set. So for your understanding, what I did is I prepared a simple Excel sheet. If you go through this Excel sheet, you can easily understand how to choose that particular root node or intermediate node. So this left hand side represents my input data set. So what is this input data set consist of? There are four features, that is outlook, temperature, humidity, and wind. So based on this, I need to find whether play will happen or not. So play tennis or some other game. So here my aim is based on these input features, I need to find whether the play will happen or not. So for example, sunny outlook, hot temperature, and high humidity and weak wind, there is no play. And rainfall, cool, normal, and weak. So then decision is yes, something like this. There will be multiple rules are given. Based on this, I need to construct a decision tree. If I get a new record, I need to find whether the play will happen or not. And if you see right hand side, here I showed a simple calculation of Gini index, how to calculate the Gini index for each feature. So please carefully observe how I am going to show you a Gini index. Once if you are able to calculate the Gini index for each feature, then you can select the best node at the root and then followed by intermediate nodes. So as we know, the formula to calculate the Gini index is 1 minus summation of I equal to 1 to n pi square. So first I need to find the probability for individual feature, and finally I need to calculate the Gini index like this. So see here, I have prepared separate tables for each feature. So outlook, temperature, humidity, and wind. So there is no complex calculation, just very simple calculations. If I take outlook, see here in outlook, how many unique values are there? Sunny, overcast, and rainfall. So three unique values, sunny, overcast, and rainfall. How I prepared these table is, so if outlook is sunny, how many S are there? How many no are there? So let us take simple example here. So see here, just I will filter outlook equal to sunny and see. So outlook equal to sunny. Totally how many records? 5 records. Out of 5 records, 3 no and 2 yes. So that's what if you go and see my previous sheet. So 3 no and 2 yes, total 5 instances. Similarly for overcast and rainfall, so just go to other sheet again. So for rainfall. So rainfall, how many? 3 yes and 2 no, right? So just see here. So rainfall, totally how many records? 5 records. And out of that, 3 yes and 2 no. So just I listed what are how many values for yes and how many values for no, that particular feature and that particular input. And similarly for overcast, just if I filter for overcast, so filter with overcast. So see here, 4 yes and 0 no. 4 yes and 0 no. And how to calculate this Gini index for this outlook? First, individual input we need to calculate and see here what is the probability for yes. Total 5 instances and 2 yes, right? 2 by 5 is the probability for yes. And simply I can take some notepad in parallel so that so see here And so our feature is Outlook. In Outlook, I need to calculate Gini index if Outlook equal to Sunny. It's already there in the Excel sheet, but just I am going to explain one calculation so that you can understand. So where Outlook equal to Sunny. So if Outlook equal to Sunny, see here how I can calculate Gini index. Gini index formula is 1 minus summation of pi square. So where pi is the probability for each input of that, each class of that feature. 1 minus. So what is the probability of yes? So how many yes? 2. And total how many instances? 5. 2 by 5 whole square. So maybe summation, right? I can put everything in a parenthesis. So whole square plus. So what is the probability for no? So that is 3 by 5. 3 by 5 whole square. And so in the Excel sheet, you are seeing, right? 1 minus 2 by 5 whole square minus 3 by 5 whole square. So why I have written means I remove these braces, parenthesis. So if I remove that parenthesis, if that plus will come outside means minus of 2 by 5 whole square minus 3 by 5 whole square. 3 by 5 whole square. 1 minus 2 by 5 whole square minus 3 by 5 whole square. So if you calculate this, so if outlook is sunny, so what is the Gini index is 1 minus 2 by 5 whole square minus 3 by 5 whole square. So if you calculate 1 minus 2 by 5 whole square is 0.16 minus 0.36, that is 0.48. So what is the probability? What is the Gini index if outlook is sunny? And similarly, what is the Gini index if outlook is overcast? That is probability for yes is so 1 minus so 4 by 4. So probability for yes is 4 by 4. Probability for no is 0 by 4. That is 1 minus 4 by 4 whole square minus 0 by 4 whole square. That is 1 minus 1 minus 0. That is 0. And similarly, probability for rainfall for S is 3 by 5, for no is 2 by 5, and Gini index for rainfall is 1 minus 3 by 5 whole square minus 2 by 5 whole square, that is 0.48. Now see here how I can calculate the final Gini index. So Gini index for complete outlook. Previously I have calculated Gini index for each input value. Now how I can calculate the Gini index for outlook is, so complete combined Gini index for outlook is, so see here how many features for outlook equal to sunny. So total sunny outlook, so 5 records, and for overcast 4 records, for sunny 5, overcast 4, and for rainfall totally how many records? 5 records. And totally how many records in my data set? 5 plus 4 plus 5 is 14. So what is the probability for sunny outlook? 5 by 14. And for overcast, 4 by 14. For rainfall, 5 by 14. And how I can calculate final combined Gini index is sunny outlook probability, sunny probability into, so sunny probability into Gini index of, so Gini index of outlook equal to sunny outlook equal to sunny. Gini index of outlook equal to sunny. Just a minute. So Gini index outlook equal to sunny. And similarly, I need to calculate so probability. So probability of sunny means outlook equal to sunny probability. Next overcast probability into outlook Gini index of overcast. And so rainfall probability into outlook is rainfall. So substitute all those values. That is 5 by 14 into that is I think 0.48. Just see what is the Gini outlook sunny means Gini index for outlook equal to sunny is 0.48 and Gini outlook overcast is 0. Gini outlook rainfall is 0.48. So 5 by 14 into 0.48 plus 4 by 14 into 0. So that is Gini outlook overcast is 0 plus 5 by 14 into 4.8. Just use your calculator or Excel formula. So then you can get the final Gini index for outlook. So Gini index for outlook is 5 by 14 into 0.48 plus 4 by 14 into 0 plus 5 by 14 into 0.48. So final Gini index for outlook is 0.342. Similarly, so this is outlook Gini index. You need to calculate Gini index for temperature, Gini index for humidity, Gini index for wind. So just see the firstly see the calculation for temperature. For heart, how I can calculate the Gini index is 1 minus. So how many heart records? 4. So 1 minus 2 by 4 whole square minus 2 by 4 whole square. See here, Gini index temperature equal to heart 1 minus 2 by 4 whole square minus 2 by 4 whole square, that is 0.5. And similarly for cool is 1 minus 3 by 4 whole square minus 1 by 4 whole square. So probability for yes is 3 by 4. Probability for no is 1 by 4. 1 minus 3 by 4 whole square minus 1 by 4 whole square, that is 0.375. And Gini index for mild is 1 minus. So how many records? 6 records. 4 by 6 whole square minus 2 by 6 whole square. That is 0.445. And finally, how I can calculate the final Gini index is Gini index for probability means hot probability into Gini index hot and cool probability into Gini index for cool and mild probability into Gini index for mild. So that is 4 by 14. Total how many records? 14 records. 4 by 14 into 0.5 plus 4 by 14 into 0.375 and 6 by 14 into 0.445, that is 0.439. And similarly calculate the Gini index for humidity and Gini index for wind. So here there are only two values for humidity, right? High and normal. So high 7 instances and normal 7 instances. Probability for S is 3 by 7. Probability for no is 4 by 7. And for normal 6 by 7 for yes and 1 by 7 for no. And calculate Gini index 1 minus 3 by 7 whole square minus 4 by 7 whole square, that is 0.489. And Gini index for normal is 1 minus 6 by 7 whole square minus 1 by 7 whole square, that is 0.244. And similarly final Gini index for humidity is probability into this Gini index plus probability of normal into this Gini index, that is 7 by 14 into 0.489 plus 7 by 14 into 0.244, that is 0.367. And similarly calculate wind. So weak, strong, And for week, 1 by 1 minus 6 by 8 whole square minus 2 by 8 whole square, that is 0.375. And Guinea for wind equal to strong is 1 minus 3 by 6 whole square minus 3 by 6 whole square, that is 0.5. And finally, total Guinea index for wind is 8 by 14 into 0.375 plus 6 by 14 into 0.5, that is 0.248. Just put down all these Gini indexes at one place. So once if you calculate the final Gini index, so see here, the Gini index for Outlook is 0.342, whatever the calculations we did, right? So compare with this, whether we place the same or not. So Gini index for Outlook is 0.342 and Outlook is 3.42 and Gini index for temperature is 0.439. Gini index for humidity is 0.367 and Gini index for wind is 0.428. And if you remember our starting of the session, what I told is the feature which is having less Gini index will be placed at the root node. So because we know the definition of Gini index, which is the impurity, if I take that feature, how much it is able to calculate means placing that feature in the incorrect classification. So this Gini index, higher Gini index will represents higher incorrect classification. So low Gini index will indicates it may be possible for less wrong predictions. So that's why here if you see Outlook is having less gain index. So we are going to place Outlook as the root node. So the feature Outlook, which plays a major role, which is giving less gain index means there are less chances of predicting that output in a wrong classification. So that's why Outlook is as the root node. But here, so once my root node is decided, that is Outlook. So how many values for Outlook? There are sunny, overcast, and rainfall. So now there are three branches. So root node is decided, and so there is one input is sunny, and another input is overcast, and another input is rainfall. So now I need to find these intermediate nodes, and finally we need to find the final decision whether play will happen or not. Now I know my one feature is Outlook. So now leave out Outlook. Next thing is I need to find what will be my intermediate nodes. I need to do the same calculations gain index, but now the change will happen in the tables. What will happen? I know that Outlook is my root node. So now no need to think whether Outlook is means Outlook. I know there are three branches, that is Outlook sunny, Outlook overcast, Outlook rainfall. Now just concentrate on this left side. Outlook is sunny. So Outlook is sunny. If I go to my Excel sheet, so Outlook is sunny. So totally how many records? There are 5 records. Now up to this part, already I know this is Outlook is sunny on the left hand side branch. So what I need to do? I need to find whether next intermediate node will be temperature or humidity or wind. So whether that next intermediate node, so which one I need to take. Here if you see, so I know Outlook is sunny. But here I placed a question mark because I don't know whether that may be temperature or humidity or wind. I need to find the same calculation by using wind. Now filter out the records which are Outlook equal to sunny. And same Gini index calculation I need to do for these three features, temperature, humidity, and wind. And after calculating Gini index, and whichever will get the less Gini index, we are going to place at the next intermediate node. Let us go and see here. So this is outlook equal to sunny. And now outlook equal to sunny again for temperature. So again for temperature. So there are three values, right? Hot, mild, and cool. So hot, mild, and cool. So now I need to filter these values. So for example, if I take hot, so both are no. So hot, so both are no. So that is 0, 2, 2. So total instances for hot is 2 and all 2 are no. And 0, yes. And similarly for cool and mild. So just to filter mild. So for mild, 1 yes and 1 no. So 1 yes and 1 no. So for mild, 1 yes and 1 no. And for cool, 1 and 0. So just if you filter cool, so only 1 yes and 0 no. And apply the same formula. So that is Gini index calculation. Now, so see the Gini index, how I am calculating. I know outlook equal to sunny. Now for different combinations of temperature, I need to calculate the Gini index, and final Gini index for outlook sunny and temperature, I need to calculate. So temperature hot. So temperature hot. So outlook equal to sunny and temperature is hot. How I can calculate the Gini index is 1 minus. So for yes, what is the probability? 0 by 2 whole square minus 2 by 2 whole square. That is 1 minus 0 minus 1, that is 0. So 0 by 2 whole square is 0. 2 by 2 whole square is 1. 1 minus 0 minus 1 is 0. And similarly calculate for uh, cool temperature. 1 minus 1 whole square minus 0 by 1 whole square. That is 1 minus 1 minus 0, that is 0. And similarly for mild, 1 minus 1 by 2 whole square minus 1 by 2 whole square, that is 0.5. So this is for temperature. And similarly separate Gini index for humidity. So humidity, so just if you filter humidity, so humidity there are two values, high and normal. So if I separate high, so see here, all three are no. And for normal, all two are yes. So total 5 instances. So if it is high, all three are no, 3 instances. For normal, 2 yes and 0 no. So just apply the same Gini index formula. So Gini index outlook sunny and humidity high. So that is 1 minus 0 by 3 whole square minus 3 by 3 whole square, and that is 0. And for normal, 1 minus 2 by 2 whole square minus 0 by 2 whole square, that is 0. And final Gini index for humidity is 3 by 5. So total how many records? 5 records. 3 by 5 into Gini index for this is 0. And 2 by 5 into Gini index for this is 0. So combined Gini index I am calculating. Here also Gini index for final outlook is, so Gini index separately for temperature hot is 0, temperature cool is 0, and temperature mild is 0.5, right? And how I can calculate the final combined Gini index is total 2, and how many records? 5, right? 2 by 5 into 0 plus 1 by 5 into 0. So 1 by 5 into 0 plus total 2 by 5 into Gini index for this temperature mild is 0.5. So 2 by 5 into 0 plus 1 by 5 into 0 plus 2 by 5 into zero point 0.5, that is zero point 0.2. And similarly calculate Gini index for wind. So Gini index for wind. So if you filter out wind records, so wind records. So there are how many values? Weak and strong. If you filter out weak, so 2 no and 1 yes. And for strong, 1 no, 1 yes. So one no, one yes, and totally two records for strong and three records for weak. Weak. So like this, if you calculate Gini index for this, Gini index for outlook equal to sunny and wind weak. So 1 by 3 whole square minus 2 by 3 whole square. So that is 0.44, and 1 minus 1 by 2 whole square minus 1 by 2 whole square, that is 0.5. And combined Gini index is 3 by 5 into 0.44 plus 2 by 5 into zero point 0.5, that is 0.466. So totally if you filter out and if you list out the Gini index for this sunny outlook, and these are the temperature and humidity and wind, right? Temperature Gini index is zero point 0.2 and humidity Gini index is 0 and wind Gini index is 0.66. Next intermediate node will be humidity. So humidity value is 0, right? The Gini index for humidity is 0. If you see, my next intermediate node will be humidity. So like this, we need to calculate the Gini index for each feature. And similarly, if you see outlook equal to overcast, so let's leave this branch. We can find out these decisions later. So let's look at this outlook equal to overcast. Outlook equal to overcast, just filter it out. So outlook equal to overcast. So outlook equal to overcast, there is no, right? Means there is no no. So all are yes. If outlook is overcast, so no need to consider temperature or humidity or wind. So irrespective of these features, the decision is yes, the play will happen. So if it is again yes and no, there will be two branches. But here there is no two branches because irrespective of these other input features, whether it is a temperature, or humidity or wind, irrespective of this, the decision is yes. So that's why if you see my next branch, so if I take outlook equal to overcast, so irrespective of these humidity or temperature, irrespective of other features, the decision is yes. And again consider outlook equal to rainfall. Outlook equal to rainfall, or so either you can consider this, or here what I am doing is humidity normal and high. Humidity normal and high. So now outlook is sunny and humidity is normal and humidity is high. So if I separate outlook equal to sunny, outlook equal to sunny, and humidity is high, irrespective of other features, the decision is no. And similarly, if humidity is normal, irrespective of other features, it is yes. So if you see the same, I filtered means when we need to again calculate Gini index, we may get a question, are is telling calculate the Gini index. Some of the features are is telling directly take the decision, because if I filter it out here, so there is no yes and no conditions, right? Means only one class. If sunny outlook and humidity is normal, so there is no other class, yes and no. There is no two classes or multiple classes. Only one class, that is decision is yes. That's why I'm taking finally leaf node is yes. If humidity is normal, yes. And humidity is high, no. So if humidity is high, if humidity is high, no. So in case, for example, here if I get yes, then again I need to calculate the Gini index for the remaining features, then I need to take. But here no need to do that Gini index because irrespective of other features, my decision is no. And Similarly, so I know outlook equal to sunny. There are two branches, humidity normal and humidity high. So humidity is normal is yes and humidity high is no. And if outlook is overcast, it is always yielding yes. And similarly for rainfall, so for rainfall, so if outlook is rainfall, so if outlook is rainfall, but here if you see there are two classes. Directly I cannot take the decision. If outlook is overcast, so I'm taking the decision because only one class that is yes. If outlook is overcast, it is always yielding yes. So first clear these filters so that you can understand. See here, if outlook is overcast, only one class that is yes. That's why I'm not taking an index. But if you see outlook is rainfall, so there are two classes, yes and no. So what I need to do, again, I need to calculate the gain index for temperature, humidity and wind, and which is having less gain index that will be placed as the intermediate node. So similarly, calculate gain index for temperature. So for temperature, there are two features, cool and mild. Just filter out that Excel, you can get these values. One yes, one no, the total two instances. Mild, two yes and one no. So totally three instances. Calculate the gain index for outlook, temperature cool and temperature mild. So 1 minus 1 by 2 whole square minus 1 by 2 whole square, that is 0.5. And for mild, so 1 minus 2 by 3 whole square minus 1 by 3 whole square, that is 0.44. And similarly calculate for rainfall and temperature. Outlook equal to rainfall and temperature. So finally, final combined gain index for temperature and humidity. So for high, there are two instances, normal three instances, that is 1 minus 1 by 2 whole square minus 1 by 2 whole square. And for normal, 1 minus 2 by 3 whole square minus 1 by 3 whole square, that is 0.44. And calculate the combined gain index for humidity. And for gain index for wind, so weak, there are three instances, strong two instances, 1 minus 3 by 3 whole square minus 0 by 3 whole square, 1 minus 0 by 2 whole square minus 2 by 2 whole square. That is, this is the combined gain index for the outlook, rainfall and wind. So if you see temperature 0.466 and humidity 0.466 and wind, so it is 0. So nothing but next intermediate node will be wind. But again, wind is having two values, that is strong and weak. And now I know outlook is rainfall. Now, so wind is my intermediate node. Again, I need to see there are two values for wind, right? So strong. So if it is a strong, only one class, the decision is no. So no need to calculate again gain index for the remaining features. If it is having multiple classes, then you need to apply gain index formula. And if it is weak, so it is always yes. So final my decision tree will looks like, so if wind is strong, no. If wind is weak, yes. So finally this is my decision tree. And based on this decision tree, you can prepare if else conditions. So see here, if outlook sunny, if outlook sunny, so if outlook sunny, if outlook sunny, so then there are three branches, right? If outlook overcast and if outlook rainfall. So this is simple if statements, maybe in your C programming or Python programming or Java programming, simple if else statements are there, right? Similar way, we are having simple if else statements. If outlook equal to sunny, Again, what I need to check? If humidity. So again, intermediate branches, if humidity is normal, so play will be always yes. And else, else if humidity is humidity is high, play will be no. Play will be no. So here play will be yes. And similarly, outlook equal to overcast. So play will be always yes. So once if you construct your decision tree, next will be this simple if else statements. If wind, so if outlook equal to rainfall, if wind equal to strong, if wind equal to strong, so play will be no. Else if wind equal to weak, so play will be yes. Play will be yes. So these are the simple if statements. If I get a new record, so once if your decision tree is constructed, so finally it will choose these if else statements. Let us take something, means instead of new record, just I will take these inputs. So now, so find the decision whether play will happen or not. So whether play will happen or not. So see sunny outlook. So which if statement it will go through? So it will go through this if statement. And if sunny outlook, what I need to check? Humidity. So if humidity is high, so then play will be no. So if you see the decision also, play will be no. So let us take this condition. So see here for this second record. So sunny outlook and the humidity will be high. So the play will be no. Let us take another record. So next, see this. We'll finish this session. So see here, if outlook is equal to overcast, what is the output decision? Output class is always yes. And similarly, once if you are able to construct your decision tree, so next you can able to find out your decision. So see here, outlook equal to rainfall. Which if statements it will execute? It will execute this if statement. And here outlook is equal to rainfall. Then if it is a rainfall, what I need to check? Wind. So here wind is strong. So play will be no. So for this fourth record, so play will be no. Play will be no. So because it will execute these simple if else statements. It will follow these if else statements once if you are able to construct your decision tree. So that's all friends, how to construct a decision tree in detail we discussed, right, by Gini index. You can practice same example with different databases like diabetes or heart disease or COVID-19. Take any classification problem, try to calculate Gini index for each feature, and then which is having less Gini index will be placed at the root, and next to calculate the branches, and finally you need to lead to the leaf nodes which will make the final decision. That's all for today's session. Thank you all.